Hello everyone, my name is Rahul, and this session is about the basic network application, that is ping, how it works, right, in network environment. And I believe this application is used by every network engineers, whether they are working in voice platform, whether they are working on the data platform, on firewall, proxies, and everywhere. This is the basics of protocols which they are using. Before going to the session further, let me give the brief about myself. My name is Rahul Mora, and I am having around 17 years of experience in the industry, and that includes mainly on the voice platform, that is Cisco, Avaya, Genesys, and Ericsson servers. Also, I'm having experience in the data networks like routers, switching, switches, right? So, in my experience, I uh, I have taken so many interviews for my organizations, right? And sometime I feel that I have to prepare some documents that will be useful for the candidates. They can refer to understand or to learn basic of the networking, which generally I ask for the L1 engineers, those who are just passed out from the college or their schools and looking for the job or understanding the the network basics, right? So so keeping that things in my mind, I prepared this documents, right? So let's start. So ping is the basic ICMP protocols which is used in the network environment to check the reachability of the devices which is there on the far end, right? I have captured the screenshot so that we can save the time, right? From here you can see that I'm pinging one of the device in the network, that is 10.115.233.111, right? So you can see from here that my pack the first line, that pinging this device with 32 bytes of data. What does it mean? It means that from my system one packet is initiated to the far end, that is this one, 10.115.233.111, and the packet size is 32 bytes, right? So the packet is traveling from my laptop or from my machine to the networks, pointing to the destination as this IP address. And in the second line, I get the reply from that particular IP address dot 111, and that is byte 32. Time is less than 1 millisecond, and time to live is 128 seconds. Hope. So uh, so here I am seeing that reply from the far end device, right? And that is also 32 bytes of response, and that response is reached to my machine is less than 1 millisecond. So this is the latency which we can I was referring to, right? And here I can see that time to live is 128 second. And what does it mean? It means that my packet will travel to 128 hops in the network, and if there is any loop in the network, my packet will die over there and I will not get any response. So to avoid any type of loop in the network, this parameter is used, right? That is called as time to live. And after that you will see the response, means the final response, like ping statistics from this IP address, the destination IP address. And uh, and it says that packet send is 3, packet received 3, lost 0, that is 0%, right? And approximately time to time trip time is millisecond is minimum 0 milliseconds and maximum 0 milliseconds and average 0 milliseconds, right? So here we send 3 packets from my machine to the destination, that is the far end IP address, and I have received 3 packets from there, and there was no packet loss. That's why we are seeing 0% packet loss. And Here you can see minimum and maximum and average time, that is 0 milliseconds. We will see further on these things whenever wherever we find any delay or latency, this minimum and maximum packet will change over there, right? And for those who are new to the network fields, they can how they can reach to this command prompt. They have to go to the Windows, uh, right, and type ping and whatever IP address they want to ping, right? So they can ping like this, right? Because my device is not connected to the network, so I'm getting this type of error, right? So the next is ping command, the same ping command and with the minus t. So whenever where we used to use this minus t, uh, when we need the ping continuously ping to the far end device, right? So if I'm doing this ping 10.115.233.111 minus t, that means my device is continuously sending 32 bytes of data to the far end, right? Until unless I press Control C. Control C is the break of this output, right, or the command. So where this type of commands is required, whenever there is any power shutdown activity in your infrastructure and you want to continuously ping of your network device, right? For example, if you are going to reboot your router, or you are upgrading your router, right? And reboot is required. So what you do, you just go to the command window and just start pinging that router with minus t, and you will see the continuous reply from there. And once that router is went down, you will get the RTO, that is request timeout, and then again when it's come up, you will again see the reply from that device, right? So this is the way you can continuously ping any of the network device, and this is useful for whenever you perform any network changes or reboots or iOS upgrade or anything, right, like that. And here, I mean, by using minus t, you don't have to run ping command again and again. Just one command, and it will continuously ping your far end device. Here, you can see uh, continuously ping, and whenever you need to break this command, you need to press Control C. And here you can see the stats that 19 packets was sent, 19 received, 0% loss, and here I can see that maximum is 1 milliseconds. Or we can or, or we can see further on this field also, right? So sorry for that. Okay, seems my slides get overlapped. Okay, so you can ping the network device. Earlier we pinged the network device that is in my infrastructure, my within my network, right? You can also ping the device that is outside your network. Like you can ping Google, right? Like this one, ping www.google.com, right? So once you run these commands, you will see that response from this one, correct? And it says request timeout. What does it mean? That this google.com is not reachable from my machine, right? From seeing this. But in actual, there must be a firewall which is blocking the ping response or ICMP packets from my network to the internet. That's why I'm getting the IP address of the Google with server which is near to my place, right? But as my ICMP packet is blocked in the firewall, I'm getting that request timeout. Correct? So ping response means it means that connectivity is there. If no, you are not getting the response, that doesn't mean that your network is not connected with the far end. You have to also check the layer 7, right? So might be ICMP packet is blocked like that. So you have to verify that thing also in your troubleshooting. So here you can see that packet send is 4, right? And packet received 0, lost 4, and 100% loss. Correct? So we have sent 4 packets, received 0, and lost 4%. Right? Also, I pinged one of the network device which is in my infrastructure, and that is I know that is in shutdown state. So when I'm pinging that IP address 10.115.233.112, I'm getting request timeout, right? That is 3 packets sent, 3 lost, 0%, 100% packet loss. Right? Now I'm pinging one of the device uh, that is 10, 128, 98, 70. I'm sending 32 bytes of data, and here you can see that time is 98 millisecond, time 94 millisecond, time is 81 millisecond, and 125 milliseconds, right? So there is a variation in the time, it's round trip time, right? So what happens might be because my network is not stable, right? That's why whenever 32 bytes of data is sent from my laptop to that server, there is a latency, and that latency you can see from here. The approximately round trip time in milliseconds. Minimum time is 81 millisecond. That's the third one. Maximum time is 125 seconds, milliseconds, right? And average is 99 milliseconds. So here I can see the latency in the network, right? So this is very useful for the network engineers who are in designing your network, because some application requires minimal latency, right? uh, like voice, right? And we doesn't want that there should be latency in the voice traffic. So while designing the network for the voice, we should be aware of the latency in our network, and it should be minimal, right? So these things can be asked in your interview questions, that what how you check the latency in your network, right? And what does TTL means, and how it works, right? And the next took the screenshot from the router. As of now, earlier I was taking I was initiated ping from my machine, right? Now I can take run the ping commands from the network routers, right? So this is the router, and from here I can ping any of the network device like this one, and it says sending 5 packets, 100 bytes ICMP equals to this IP address, time in is 2 seconds. So you can see the exclamation sign. So sending 5 packets. So these 5 exclamations means 5 packets are sent to the destination, and that is the 100 byte of data, right? And the next line says that success rate is 100%, 5/5. That means these five packets, which is 100 byte of data, is sent from this router to this server, and we have received 5 and send 5 packets. So 100% is success rate. And here you can see the stats, more stats of the packets, like minimum, maximum, and average, right? So minimum is 108, maximum is 110 milliseconds, and average for this packet is around 108 milliseconds, right? So here what we did, we ping one of the network device, maybe server, from the routers. So this is a way you can uh, do the ping. from your router also, right? And in case in the second screenshot, I mentioned that I'm pinging from the same router to one of the network device, that is 10.128.98.9. I'm sending 5 packets, the same ICMP packets, right? And now I'm seeing dot dot 5 dots. That means I'm sending the data to the far end, but the far end is not responding. Might be that server is shut down state, so I'm not getting the response. So I'm getting the uh, dot. So dot means that far end device is not connected or not in the network. And here you can see the success rate is 0%. That is, I sent 5 packets and all packets were lost, right? So this is a way, I mean, so basic understanding it should be with the network engineers, what they are doing, from where they are pinging, how much response or packet response they are getting from the far end. This should be basic understanding for the network engineers, whether they are working as a L1 engineer or L2 architecture level, right? And also, a ping works on the network layer. I hope you are aware of the network OSI layer, right? So ping is working on this layer, that is a layer 3, right? So I will prepare more documents like that, that will be useful for the troubleshooting, as well as those who are looking some opportunity outside their organizations, or they are preparing for the interviews, right? And if you need these documents, you can email me. You can share your email ID on the comments. I will prepare our good documents and will share with you, and share the same documents with you, right? And thanks for the watching. Thank you so much. Have a nice day. Bye bye.